Hello, today we're going to be looking at the GCSE core practical on the combustion of fuels. So we're going to be looking at how we can measure different amounts of energy released from the combustion of 5 different fuels. So today we're using alcohols. We have ethanol, propanol, butanol, hexanol and octanol. Okay, each one of those has a different number of carbon and hydrogen atoms present in them. Okay, so to do this, we're first of all going to take our first burner. These are little spirit burners, okay, which you may be able to see there. Okay, all they are is a little jar containing alcohol with a little wick, okay, just like a candle. Okay, coming out from the alcohol, it carries the alcohol up and then the alcohol will burn on the wick. Okay, and then they have a little lid which we can put on to stop the flame and to stop the fuel evaporating when they're not in use. Okay, so the first thing we've got to do with this is we're going to weigh it. So we have a 2 decimal place balance. Okay, a nice accurate balance. Okay, we're going to make sure that the balance reads 0 when we start, okay, alright, which this one does, and we're then going to put on to the scale our burner. In this case, it's 111.71 grams. So we're going to note that down, okay, in our table as an initial reading. Because we'll need to know that at the end so we can calculate how much alcohol has been burnt in the process. Okay, next we're going to take a calorimetric can. Okay, this is basically a copper can. The reason we're using a copper can as opposed to a glass beaker is that copper is an exceptionally good conductor. The more energy therefore that is conducted from the burning of the fuel into the substance which we're heating up, which is water, the more accurate our results will be. Okay, so we're going to use a clamp to hold our can in place. Now we need the can to be just above where the flame is going to be. Okay, if it's too high, okay, or too low, then we won't get all the heat from the combustion. We'll have too much of it escaping away. And also to make sure that we're keeping everything the same so that we're controlling our variables, we're going to measure and record what that height is. So in this case I've done 10 centimetres, and then for every subsequent time I do this I can then make sure that the bottom of the can is 10 centimetres away from the surface, and therefore keeping that factor the same throughout. The next thing I'm going to do is, we said we're going to heat water, so we're going to measure the temperature change by heating of the water inside the calorimetric can. To keep that constant, we're going to use fresh normal room temperature water each time, and we're going to use the same volume. So we've got a measuring cylinder and we're going to accurately measure 50 ml of water, which we're going to place in to the bottom of our can. Now if we were in a windy or drafty space, we may wish to put windshields to stop any draft blowing the heat or the flame away. Now we're fortunate today to be in a nice quiet, calm, still room, but if you were in a lab with a lot of people moving about or a lot of windows open, you may wish to place extra mats around to prevent heat being blown away and escaping from our experiment. Because remember, we want all of the heat from the burning of this alcohol to get into the water in this can. Now we're going to measure the temperature change in that water. We're going to use an ordinary liquid in glass thermometer, and we're going to make sure that our 50 ml covers the bulb. That's the little bottom bit of our thermometer. This is the bit that is used to measure the temperature, and that needs to be completely below the level of the water. If it's not, you will not get an accurate reading for the temperature. So we will take our initial temperature reading before we start. We're going to leave the thermometer in there for a minute or so to acclimatise to the temperature of the water, because liquid in glass thermometers are not instantaneous, there's a slight lag, so we'll need it to acclimatise to the temperature of the water. Okay, and once that has happened, we'll record what the temperature is. In this case, it is 23 degrees Celsius, and we can record that in our table as the initial temperature. Okay, we're then going to use our spirit burner. We're going to heat the can, and we're going to heat the can for a set amount of time. The reason we're heating the can for a set amount of time is so that it's repeatable. We want to be able to do this repeatedly and to do it every time. Okay, so we're going to heat it for 2 minutes. Okay, and so we're all set up. We've taken our initial temperature reading. We're going to use a match or a splint to light our little spirit burner. Put the match out, and as we've lit it, we've started the stop clock. Okay, and we're going to watch as the temperature in the water increases. Okay, and at the 2 minute mark, we're going to record what the temperature change is. So now we sadly have the boring bit while we wait for the 2 minutes. But it's important that you keep an eye on this and you make sure that you're getting a reasonable increase in temperature. The temperature's already gone up. It's now already at 36 degrees, and that's only after 40 seconds. So we're getting a nice, reasonable temperature change. So we know that the heat is being transferred from the burning alcohol into the can. Now after 1 minute, we're already at 44 degrees. So we've seen an increase of 21 degrees just in that 1 minute. We're nearly at the 2 minute mark. Right, so we're approaching the 2 minute mark, so we're going to make sure that we're ready to take our reading at exactly the 2 minutes. So we're at 2 minutes and we are at 67 degrees. Okay, so now we can move our can out of the way. We can use our cap. We just very carefully from the side put our cap over the top of the flame and it will put it down. We're going to leave it all to cool for a moment. Okay, we're going to record what our temperature change was. So we started at 23, we finished at 67. Okay, so that means we have a change of 44. Okay, once we're certain that our alcohol or spirit burner has gone out, okay, and is nice and cool, we're going to take it and we're going to weigh it again. Okay, now we started with 111.71 and we're now down to 110.97. Okay, which means that we've used 0.74 of a gram of alcohol to heat that can of 50 ml of water by 44 degrees. And from this information you can then work out how much energy was generated from the burning of that alcohol to heat that water. What we would then do is we would repeat the experiment so you have concordant results. Okay, so we could repeat this for this alcohol, say 3 times, so that we get a nice set of results. We would then do exactly the same, making sure we keep the volume of water, okay, making sure that we keep the height of the can the same, And between each method we make sure that we clean the bottom of the can, because there could be a sooty deposit arrive on the bottom of the can, and that soot will act as an insulator. Okay, and obviously we want the can to be cool when we start. Okay, so obviously cleaning it and running it under the tap or allowing it to cool will help with that. And then we're going to repeat that for the other alcohols. So we would do exactly the same for propanol. We would weigh it, we would set it up, we would burn it, we would measure the change, we would weigh it again, and we go on through all 5 alcohols. Okay, till we've got a nice set of results. Alright, thank you very much.